Alright, so the second half of the unit is on spheres. These are spheres. They're like, it's like a ball is a sphere. That's a sphere. We live on a sphere, so spheres are kind of important to know the properties of spheres. Spheres are everywhere. We live on a sphere. Okay, first let's go through the vocabulary. Just like a circle, a sphere has a radius. So the radius of a sphere is going to be the distance from the center of the sphere, out to any point on the sphere. Radius. You can think of a sphere as having a chord, similar to the way a circle has a chord. A sphere can have a chord, a segment whose endpoints are on the sphere. A sphere can have a diameter, and that's going to be the chord that contains the center, similar to the way a diameter works for a circle. A sphere can have a diameter. Now, there are a couple of vocabulary words that apply especially to spheres and not to circles. And one of those is a great circle. You can read that definition right there. But basically, a great circle is that largest circle that you can draw around a sphere. So picture's worth 1,000 words. So this blue would be a great circle. It doesn't have to be horizontal. It could be in any direction. So that's a great circle. Burton, pay attention. Watch the presentation, brother. No, this is a visual thing I've prepared for you. You got to see it. You can't hear the great circle. Okay? So there's a great circle. All of these are great circles. Okay? So look at this picture for a second. There are a lot of circles on this sphere. Some of them are great circles, and some of them aren't. See if you can sort of visualize to yourself which of these are great circles. Now I'm going to do a little Dora the Explorer on you. Is this a great circle? No. Why is this not a great circle? Why not? It goes all the way around. It's a smaller one. Is this a great circle? That's a great circle, okay? Because it goes through the longest distance around. From geography, are you guys familiar with the terms longitude and latitude? Raise your hand if you've heard longitude and latitude before. Okay, good, good. Put your hands down. Which circles are always great circles? Latitude circles or longitude circles? It's the longitude. So this red circle, for example, this example would be, these are lines of longitude, the ones that are going sort of through the poles. Those are always going to be great circles. But the ones going latitude, only one of those is a great circle. What do we call the great circle around the Earth, halfway between the poles? That's the equator. So the equator is a good example of a great circle. Okay, another vocabulary word, hemisphere. If you break it down, hemisphere. What do you think that root hemi means? Hemi means half. So hemisphere literally means half of a sphere. Okay, so this would be a hemisphere. This would be a hemisphere. Okay, here are a couple of formulas that we're going to be working with. A sphere has a surface area and a volume. Okay, and these are the formulas for surface area and volume. Just like when we dealt with circumference and area, R represents a radius. Now, just understand what these two concepts mean. Surface area is, it's just what it says, but it's the surface of the sphere, not the inside. If we're talking about something, filling the inside of a sphere, that's when we're talking about volume. Okay, let me just make sure everyone understands the difference between surface area or volume. Each one of these concepts are going to pop up. I want you to ask yourself, would these be best represented by surface area or volume? You with me, Paige? You ready? It's Friday. You've almost made it. Hang in there. Okay, if I wanted to know about the amount of air in a basketball, would I be talking about surface area or volume? That's volume, because I'm filling the ball. That's volume, the volume of air. What if I'm talking about the amount of rubber that it takes to make the basketball? That's going to be surface area. Is a basketball solid, full of rubber? No, it's empty inside. The rubber is just on the outside. So if I wanted to figure out how much rubber it's going to take to make a basketball, the main thing I would be concerned with is the surface area of the basketball. What if I wanted to know how much paint it would take to paint a water tower? That would be what, Margaret? That would be surface area, because it's just the surface of the water tower is being covered, not the inside. What if I wanted to know about how much water it would take to fill that same water tower? That's volume. We're on the inside. Okay? Alright. Find the surface area of the sphere. Calculate this along with me if you didn't already do it. Correct. We just use the formula. Surface area is 4 pi r squared. In this case, the radius is 7, so that's going to be 4 pi 7 squared. Can you give me an exact answer for that? 496? 196? Alright, 196 pi, that would be the exact answer. Or, what would that be as a decimal? 615.75? Okay, so it's just straightforward using of the formula. Similarly, if I want to find the volume of a sphere, I use the formula. What's the formula for the volume of a sphere? Four thirds pi r cubed. So the radius is 3, so that's 4 thirds pi 3 cubed. Okay, so I just want to make sure you understand. We could type this in the calculator. Make good use of your n over d button. So 4 over 3 pi 3. If you want to cube something or do any other power other than squared, use this caret. It's like an arrow pointing up because it moves you up. And then I can type 3. Okay? I have no idea why they call it a caret. So we get 36 pi, okay, is the exact, or 113.1. Oh no. Okay, any questions so far? Alright, going back to example 2. Anoop and Evan. Example 2 takes one extra step more than example 1 or 3 did. So please pay attention. The circumference of a sphere is 12. Oh, circumference? Wait a minute. I thought we were doing surface area and volume. We haven't seen circumference since the last unit. Please do not forget the skills that we learned in the previous unit. Circumference is not going away. You have to keep that in the front of the brain. So what's the formula for the circumference of a circle? Right. Circumference equals 2 pi r. So as soon as they mention circumference, the first thing you should do is go ahead and write down the circumference formula. The circumference is 12 pi. So just take your 12 pi and put it in the circumference formula. So that becomes 12 pi equals 2 pi r. What do you think I'm going to do now? Divide by 2 pi, exactly. Okay, that way these cancel out, these pi's cancel out completely, and we just have 12 divided by 2. So we're just going to get 6. Okay, the radius is 6. Am I finished? No, because what are we being asked to find? We're supposed to find the surface area. Okay, but in order to find the surface area, we needed the radius. So we needed to do that. So we found the radius. Now we can find the surface area, which is the formula is 4 pi r squared. Okay, but now that we know that the radius is 6, we can take this and substitute it in. So that's going to be 4 pi 6 squared. So that's going to be 144 pi. Which is 452.39. Irvin, that's 1. Okay, any questions on example 2? Okay, vocabulary. Kelvin, can you tell me the name the center of the sphere? T. The center of the sphere is simply T. It's just a letter. It's just a point. Okay, Jesus. Can you name a chord of the sphere?
QR.
QR would be a good example of a chord. Okay? Pay attention to the symbol that you're putting over it. Alright? Don't just leave it QR. Make it segment QR with a little line over it. Don't forget that. Okay? Marisa, can you tell me a radius of the circle? QT would be a good radius. There are more that you could say. Name another radius, somebody. PT. Name one more. Right. All of these are example of radii. Okay? Greder, can you tell me the diameter of the sphere? Correct. PS would be an example of the diameter of the sphere, segment PS. Again, make sure you're putting the segment symbols over your answers. Okay? Now, for number 5, we're supposed to find the circumference of the great circle that contains P and S. Write your answer in terms of pi. So as soon as they say circumference, what am I going to write down?
2 pi.
Right.
Or you do pi.
Sure. Alright, circumference is 2 pi times the radius. We're given that the radius is 7. So we just substitute in 7. Okay, so of course that's 14 pi. Any questions about number 5? Irving, that's 2. Next one is detention. Alright, find the surface area and volume. Round your answers to 2 decimal places. Alright, I'm going to pause the video, give you a couple minutes to do these problems on your own. Okay. Alright, we're supposed to be doing the surface area. So of course we're just going to use this surface area formula for all 3 of these problems, 6, 7, and 8. Okay, if we substitute in the radius, let me focus on one thing. I'm sure almost everybody got all of these problems correct. But maybe there was one person out there who just didn't notice that the 22 is the diameter, not the radius. Did anybody accidentally use 22, or did everybody use 11? Raise your hand if you used 11 on problem number 8 like you're supposed to. Okay, put your hands down. Did I fool anybody? Did anybody get tricked? Okay, just make sure on problems like number 8, don't use the diameter, use the radius. So these are the answers that you should have gotten for 6, 7, and 8. Any questions on 6, 7, or 8? Okay. Similarly, 9, 10, and 11 should be this. Yes. With pi? Well, the direction said round your answer to 2 decimal places. Okay, alright, moving on to number 12. The center of the sphere is C, the circumference is 17. So pay attention to what you're being given. We're told the circumference, so we're probably going to have to use that. Okay, circumference is 17. Well, first vocabulary. Let's see, where was I? Jessica. What is half of the sphere called? Hemisphere. Okay. Jessica, I'm going to stay with you for one more problem. How would I find the radius of this sphere? Right. We're given the circumference, so the first thing we do is we write down the circumference formula. Circumference equals 2 pi r. Since the circumference is 17, we will just substitute that. So this will become 17 pi equals 2 pi r. Alright, what's the last step, Jessica? Divide by 2 pi on both sides, correct. If I do that, okay, so this is going to cancel out. The pi's are going to cancel out. So what am I going to get for the radius?
R equals 17.
Okay, r equals 17 over 2, or that would be exact. As a decimal, just in case, what would that be? 8.5. Okay. Any questions about number 15? Okay, so Margaret, how do I find the diameter?
Just times 8.5.
Right, the diameter is always going to be twice as long as the radius. There's the radius. There's the diameter. Just double it. So what is that diameter? 17. Okay. Burton, how do I find the surface area of the sphere? Okay.
But 8.5 is R.
Okay. So what do I get for the final answer?
Where you get 907.9.
Okay. All right. Any questions about number 15? Oh, surface area of half the sphere. Not the, okay, so far we have found the surface area of the whole sphere. So thank you, gentlemen in the back, for pointing out that we're not quite done. Because it says half of the sphere, we have to divide by 2.
Yeah. And you get 453.9.
453.9.
6.
0.96.
Yeah.
Okay. All right, we got to read those directions carefully. All right, number 16. Find the radius of a sphere given the surface area. Okay, Irvin, how am I going to do this?
You put 4 pi surface area.
Okay, right, the formula for surface area is 4 pi r squared.
Number 16.
Okay, so I'm just going to substitute that in. So what's the answer? Well, so wait, so I have 324 pi equals 4 pi r squared. Okay, now what do I do, brother?
You divide 4 pi.
We divide both sides by 4 pi. Okay, that way these 4's and pi's will cancel out, and these pi's will cancel out. What am I getting for r now? 81.
Yeah.
Okay, so the radius is 81. Now, oh, that's what we're supposed to find, the radius. Okay. What? Oh, r squared. True. R squared. You don't have to yell. Alright. 81 is r squared. So what do I need to do now? Finish it up for me, Irvin. I need to take the square root. Take the square root of both sides. Okay. So what's that going to give me? Okay, so the radius is 9. Okay? So it's the same thing. It's the same thing for these problems. I'll give you 1 minute to finish these on your own. Okay. Check your answers to number 17 and 18. Any questions on number 17 and 18? Okay. Wait for number 18. All right. Number 19. The circumference of the sphere is given. What's the surface area? Round to 2 decimal places. Okay? Paige, how do I do this problem?
Well, you find the circumference, which is 330,
Mm-hmm.
diameter, which is 338,
How did you find that?
because circumference is 338 pi.
Okay? So I think I hear you saying that circumference is 2 pi r. So you're setting this equal to 338 pi. Is that not what you were doing?
Yes, it is.
Okay. So 338 pi is equal to 2 pi r. Then what did you do?
I found the radius, which is 169.
Okay. She divided both sides by 2 pi. Alright, and Paige says the radius is 169. Okay. And then what do we do?
Then I did 4 pi 169 squared
Okay.
on surface area.
So the surface area is 4 pi times radius squared. So I hear you saying 4 pi 169 squared. Okay. So that would be 114,244 pi, or this. Okay, any questions about number 19? Okay. All right, I'm going to give you 60 seconds to do these 3 problems. All right, so we're finding the volume, so we should be using this formula for all of these problems. Substitute in the radius. Again, on number 22, notice that 6 is not the radius. Do not substitute 6 into the formula. 6 is the diameter, the radius is 3. Don't make that mistake. So these should have been the answers for 20, 21, 22. Check your answers. Any questions on these 3? Okay. Similarly, 23, 24, and 25. Same thing. We're using the volume formulas. Substitute in the radius. You should come up with these answers. So check your answers to 23, 24, and 25. Any questions? Okay. Pay attention. This is not on your paper, so you need to just look up here at the screen. Is everybody looking? Everybody stop writing. Irving, time out. Okay. I want to make sure you understand how to work your calculator in terms of this operation. How do we uncube things? We know how we unsquare things. How do we unsquare things? We do the square root. So if I want to uncube things, I'm going to do the cube root. We haven't done that in this room before, so I need to make sure you know how to do the cube root. Okay? So for example, if I want to solve this equation, x to the third power equals 1,331, I'm going to do the cube root. And it looks like this. It looks just like a square root, but has a little 3 in that spot. So I'm going to do the cube root of both sides of this. Okay? Now, it's a matter of how do I put that in my calculator. So that's going to give me x on the left. Okay. If you want to do the cube root on your calculator, the first thing you need to do is type the number 3. That has to go first. Okay? I think that's true. Okay? Then I hit second, caret. If you see above the caret, it has this little x root symbol. So whatever number you had becomes the root. So now I can just go ahead and type in 1,331. So that's going to give me the cube root. So I'll just hit enter. So in this case, I got 11. All right? Okay, so if I want to solve this little equation, so I'm going to take the cube root of both sides to get x by itself. Cube root of 1, 2, 3. Okay, again, cube root, you start with that 3, then hit second caret. So this should be the cube root of 123. That's going to give me 4.97. Okay, did everybody follow that? Any questions so far? All right, now you try. Go ahead and find the cube root of both of these numbers right now. All right, what did you guys get for this one? 12? No, wait. 12 point something? Give me 2 decimals.
It's 0.599.
599? Alright, so it's 12.5, so that would be 12.6. What about this one? 9. Okay, so we all know how to take the cube root now. Find the radius of the sphere given the volume. So if we're given the volume, start by writing down the volume formula. So the volume formula is 4/3 pi times the radius cubed. Alright, so that means 2304 pi equals 4/3 pi r cubed. Alright, please watch this very carefully. There are lots of different ways you could solve this, but I think this will be the most direct way for you guys to do it. Usually if I want to get this r to the third power by itself, I just divide by whatever's in front. I'm still going to do that. I'm just going to divide both sides by 4/3 pi, just like this. Okay, I think this will be the easiest way for you guys to handle it. So I'm just divide both sides by 4/3 pi. Okay, that way all this cancels out. Now that's going to leave me with r to the third power equals. Now all of this you can type in your calculator. You might need to help me remember it when I change screens. Number 626. My memory is so bad. It's all about your n over d button. 2,304 pi over. Okay, how am I going to make a 4/3 down here? Just hit your n over d button again. So you can put a fraction inside of a fraction, no problem. So 4/3 pi. Okay, so you can just type it all in there. And we get 1,728 that way. I think that's the easiest. Okay, but what am I going to do now? Right, we got to take the cube root to get r by itself. We're going to have to do the cube root. $12. Okay, so r turns out to be 12. Any questions about number 26? Alright, I'm going to give you 60 seconds to do number 27 on your own. Alright, check your answers to number 27 and 28. Any questions about 27 and 28? Yes. Completely different answer. Okay. Did you do 33.51 equals 4/3 pi r cubed? Did you divide this by 4/3 pi? And what did you get? Time yet. All right, look at number 29 real quick. The problem mentions a sphere inscribed inside of a cube. Well, here's the deal. First of all, you need to know how you do the volume of a cube in the first place. Did you guys know that the volume of a cube is length times width times height? So in this case, I mean, it's a cube, so the length, width, and height are all the same number, so we call it x. In other words, the volume should be x times x times x, which is x to the third power. But we're told that the volume of the cube is 8. That means this is 8 is equal to x to the third power. If I were to take the cube root of both sides, I'm going to get that x is 2. All right, it's time to pack up now. But look, if x is 2, that means this edge of the entire cube is 2. But what does that tell you about the radius of this cube, though? Wait, the whole distance across is 2. So the radius is going to be 1. So then I could calculate the surface area of the sphere using a radius of 1. I don't. Alright, so if the side of the box is 2, that would be equivalent to the diameter of the sphere. So if the diameter is 2, then the radius is going to be 1. So the radius is 1. Now, what were we being asked to find? Let's see. The surface area and the volume of the sphere. So, now it's time to do the sphere. Okay. Well, surface area of a sphere is 4 pi r squared. If the radius is 1, then that's just 4 times pi times 1. So that's just 4 pi. So that's 12.57. We are also supposed to find the volume. The volume is 4/3 pi r cubed. Alright, well, if the radius is 1, this is going to go away, so that's just 4/3 pi, or 4.19.